6.1 continued again. Inverse function values. So example 3 says find the degree measure. Okay, so we're going to want our answers in degrees of theta if it exists. Alright, so we have theta equals arctan of the square root of 3. Okay, so for arctan, theta is between negative 90 degrees and 90 degrees. Okay, so it's negative pi over 2 to pi over 2, but we're talking about degrees. So we're going to say negative 90 degrees to 90 degrees. Okay, so this is positive, which means that we are talking about quadrant 1. Okay, if it was negative, then it would be in quadrant 4. So if we take the tangent of both sides, I have tangent theta equals the square root of 3. Okay, so in quadrant 1, okay, so tangent is y over x, so we have y square root of 3 over x is 1. And then from our 30, 60, 90, we know that the radius is 2. Okay, so the angle that we're looking at here is the 60-degree angle. So that means that theta is equal to 60 degrees. You could have also put this in your calculator. Okay, so theta equals tan inverse of square root of 3. So if I did tan inverse of square root of 3, I would have gotten 60 degrees. Okay, make sure you check your mode. So we're talking about degrees here, so your calculator needs to be in degrees. Okay, so for cosecant, for B, we have, so for cosecant, theta is in between negative 90 degrees and 90 degrees, but theta cannot equal 0 degrees. Okay, cosecant is in quadrants 1 and 4. Scroll this down some. So quadrants 1 and 4. So since this is negative, we are going to be in quadrant 4. Okay, so if I take cosecant of both sides, I have cosecant theta equals the negative square root of 2. Okay, so remember that cosecant is r over y. So if I draw this in the fourth quadrant, I have r is square root of 2 and y is negative 1. Okay, so remember that r is always positive, so that negative has to go with the y. Okay, and this comes from a 45, 45, 90, so my other side is going to be 1. And then this angle here, so we're from negative 90 degrees to 90 degrees. Okay, so this angle going down underneath the x-axis is going to be negative. So that is going to be a negative 45-degree angle. Okay, so theta equals negative 45 degrees. Okay, there is a way to put this in your calculator, and we will talk about that. Okay. Okay, so use the following to evaluate these inverse functions on a calculator. So let's talk about cosecant theta. So I'm just going to write a generic equation. So we have y equals cosecant inverse x. Okay, so that's the same thing as saying cosecant y equals x. Okay, and then if we use the reciprocal identities, we would have x is equal to 1 over sine y. Okay, and then to get sine by itself, we would have sine y equals 1 over x. Okay, then we want to get y by itself, so we're going to take sine inverse of both sides. So we have y equals sine inverse of 1 over x. Okay, so that means For y equals cosecant inverse x, I can also plug in y equals sine inverse of 1 over x. So I could have plugged in here, I could have plugged in y equals sine inverse of 1 over negative square root of 2. So negative 1 over square root of 2. Okay, so sine inverse of negative 1 divided by the square root of 2, which would have given me negative 45 degrees. Okay, and this works for so secant and cosecant. So secant, its reciprocal is cosine. So if you wanted to evaluate the inverse secant function, you would put cosine inverse of 1 over x in your calculator. And then as for cosecant, which we just did, cosecant inverse, you would put sine inverse of 1 over x in your calculator. Okay, and these work out all the time for any quadrant, because recall from our previous video that sine and cosecant are both in quadrants 1 and 4. Okay, and then cosine and secant are both in quadrants 1 and 2. But when we're talking about tangent and cotangent, tangent is in quadrants 1 and 4, and then cotangent's in quadrant 1 and 2. Okay, so when the value of cotangent is positive, you can plug it in like normal because they both exist in quadrant 1. Okay, so when the value of cotangent is positive, you can use tan inverse of 1 over x. Okay, the problem comes if x is less than 0. So if x is less than 0, that means that cotangent is in quadrant 2, while tangent is in quadrant 4. Okay, so just plugging in tan inverse of 1 over x is going to give you an answer in quadrant 4, which does not exist for cotangent. Okay, so this is why we add 180 degrees. So if we're looking at our quadrants here, so cotangent exists in quadrant 1 and quadrant 2. Okay, so if we do tan inverse of 1 over x, we're going to get an angle here in quadrant 4. Okay, adding 180 degrees will bring us into quadrant 2. Okay, so if x is less than 0, so if x is negative for cotangent inverse, you have to do 180 plus tan inverse of 1 over x. Example 4. Use a calculator to approximate each value. So A, find y in radians if y equals secant inverse of negative 4. Okay, well, secant inverse of x is equal to cosine inverse of 1 over x. So we can say y is equal to cosine inverse negative 1 over 4. Okay, and remember, this is asking for radians, so you have to change your mode to radians. And then cosine inverse of negative 1 divided by 4. Okay, so this is approximately 1.82 radians. Okay, B, find theta in degrees if theta equals arc cotan of negative 0.2528. Okay, so remember for cotangent that if this is negative, which it is, this is negative, that we must use cotan inverse of x is equal to 180 degrees plus tan inverse of 1 over x. Okay, so we have theta equals tan inverse of 1 over, so it's going to be a negative 1, over 0.2528. Okay, and then plus 180 degrees. Alright, so theta equals, so let's do tan inverse negative 1 divided by 0.2528. Okay, degrees. So I need to change my calculator back to degrees from radians. Okay. So I get negative 75.81. Okay. This is going to be in quadrant 4. So remember, when we go under the x-axis, it's going to be negative. This is in quadrant 4, where cotangent does not exist. Okay. So we add 180 degrees, and we get 104 degrees, which exists in quadrant 2. Okay, so 104, so theta is approximately 104.19 degrees. Okay, so by adding the 180 degrees, we get an answer for cotangent that is in quadrant 2. Okay, and this is just a notice of what I've been saying so far. Be careful when using a calculator to evaluate the inverse cotangent of a negative quantity. Okay, enter the inverse tangent of the reciprocal of the negative quantity, which returns an angle in quadrant 4. And then because inverse cotangent is negative in quadrant 2, adjust the calculator result by adding pi or 180 accordingly. I do want you to note, however, that cotan inverse of 0 is pi over 2, or 90 degrees. Okay, you won't be able to put that into a calculator, because if you did tan inverse of 1 over x, you would have 1 over 0. Okay, which we can't divide by 0. So you'll need to remember that cotan inverse of 0 is pi over 2. Alright, so example 5. Evaluate each expression without using a calculator. So we have cosine of sine inverse of 2 over 3. Okay, so this is our angle right here for cosine. Okay, so we know that our angle theta is equal to sine inverse of 2/3. So that means that sine theta is equal to 2/3. Okay, so then if I were going to draw, so I'm going to draw a graph. Remember that sine inverse, if it's positive, it's in quadrant 1. Okay, so we're going to draw quadrant 1 here. And I know that sine theta is y over r. So this is going to be 2 over 3. And then if I do the Pythagorean theorem, I will find out that my missing side is square root of 5. Okay, so remember, x squared plus y squared equals r squared. And we know x and we know r. Okay, so we have to find, we know y and we know r. We have to find x, which is square root of 5. Okay, so then cosine theta would be x over r. So cosine theta is equal to square root of 5 over 3. Okay, here we have secant of cotan inverse of negative 15 over 8. So again, this is our angle. So we're going to set up theta equals cotan inverse of negative 15 over 8. So this means that cotangent theta equals negative 15 over 8, which is x over y. Okay, so this is negative, and since we're talking about cotangent, negative input for cotangent is going to be in the second quadrant. Okay, so that means that x is negative 15, sorry, this is badly scaled, negative 15, y is 8, and then we solve for our missing side, which would give me 17, using Pythagorean's theorem. Okay, so then that means that secant theta, which is going to be r over x, would be 17 over negative 15, which would give me negative 17 over 15. Example 6. Evaluate each expression without using a calculator. So we have sine of arctan of 4 over 3 minus arc cosine of 12 over 13. Okay, so we're going to go back to the difference identities for sine. Okay, so if we let arctan of 4 over 3 equal A, and then arc cosine of 12 over 13 is B, we can rewrite this equation. Okay, so we have sine of A minus B is equal to sine of A cosine B minus cosine A sine B. Alright, so then, if I rewrite this, sine A, okay, so we don't know sine A or cosine B. So we need to use these values here to figure out what angle A and what angle B is. So I'm going to come down to the bottom. Okay, and we're going to talk about angle A first. So angle A, this gives me tan theta equals 4 over 3. Okay, so I got that from here. So just set that up and then take the take tangent of both sides. So tan theta equals 4 over 3, and we know that is y over x. Okay, because 4 over 3 is positive, that means that we are in quadrant 1. Okay, so y is 4, x is 3, and then if I do Pythagorean theorem, I get r is 5. So x is 3, y is 4, r is 5. Okay, so that's angle A. Angle B, this is arc cosine. Okay, so arc cosine of 12 over 13 would give me cosine theta equals 12 over 13, and that is x over r. Okay, again, this is positive. Okay, so if it's positive for cosine inverse, then we are going to be in quadrant 1. Okay, so I have x is 12 and r is 13. And then that would give me y is 5, using the Pythagorean theorem. So x equals 12, y equals 5, and r equals 13. Okay, so then we want to plug in. So sine A would be angle A over here, so y over r. So that would be 4 over 5. Okay, then I have cosine B. So cosine B is going to come from angle B. So cosine is x over r, and that gives me 12 over 13. Okay, you can also get that from whenever you set up the equation here, because this is cosine B, and this is tangent of A. Okay. So then we have minus cosine A. So cosine A is going to come from this angle over here, from angle A. So that's x over r. So that's going to give me 3 over 5. And then last we have sine B. So that's going to come over here from angle B. So sine B is going to be y over r. So that's going to give me 5 over 13. Okay, so then I just multiply these out, and I have 48 over 65 minus 15 over 65, which is going to give me 33 over 65 as my answer. Okay. B, I have sine of 2 arc cotangent of negative 5. Okay, so we're going to let this be A. And the formula we're going to use is the double angle identity because we have a 2 here. So sine 2a equals 2 sine a cosine a. Okay, we're only dealing with one angle this time. So let's go ahead and draw that. Okay, and we're talking about cotangent. So cotangent for a negative input is going to be in quadrant 2. Okay, so I'm going to write cotan theta is equal to -5. Okay, and cotangent is x over y. So we have -5 here and a 1 there. And then Pythagorean's identity, Pythagorean theorem would give me square root of 26 for my radius. Okay, so we have x equals -5, y equals 1, and r equals the square root of 26. Alright, so I want to plug my values back in. So I have sine of 2a equals 2 times sine a. Okay, so sine a is going to be y over r. So that would be 1 over the square root of 26. And then cosine a is going to give me x over r. So that's -5 over the times the square root of 26. Okay, so if I multiply these out, I have -10 over 26. Okay, no square root because the square roots are going to cancel out. So -10 over 26, which is going to give me -5 over 13. Example 7. Okay, so we want to write each trigonometric expression as an algebraic expression in U for U greater than 0. Okay, so we have cotangent of secant inverse of U. Okay, so that means that secant theta equals U. Okay, so this is our angle, and if we take secant of both sides, we'll have secant theta equals U. Okay, and that's equal to r over x. Okay, and we're talking about secant, and U is positive because it states up here that U is greater than 0. So that means that we are in quadrant 1. Okay, because secant inverse for a positive input is in quadrant 1. Okay, so that means that U is going to give me U for R, U for R, and then X is going to equal 1. Okay, so if we do Pythagorean's identity, I have X squared, so 1 squared, plus Y squared equals U squared. Okay, or Y squared equals U squared minus 1. So y equals the square root of u squared minus 1. Okay, we know this is positive because we're in quadrant 1, so we know y is positive. Okay, so that means y is going to be u squared minus 1. So x equals 1, y equals u squared minus 1, the square root of u squared minus 1, and then r equals u. So then cotangent of theta is x over y. So that would give me 1 over the square root of u squared minus 1. Okay, and we always need to rationalize our denominators. So we're going to multiply the top and the bottom by u squared minus 1. So u squared minus 1 times the square root of u squared minus 1. Okay, so it's going to give me the square root of u squared minus 1 over u squared minus 1. Okay, so that's my answer. Cotangent theta equals the square root of u squared minus 1 over u squared minus 1. B, okay, so we have sine of 2 cosine inverse of u. Okay, so notice this 2 here. That means we're going to be using a double angle identity. So we'll let cosine inverse of u be a. So we have sine of 2a equals 2 sine a cosine a. Alright, so we know if I take the cosine of both sides here, for a, if a is my theta, I have cosine theta, or cosine a, equals u. Okay, and we know cosine is x over r. Okay, we also know that u is still positive because that's what they tell us in the directions. So cosine inverse for a positive argument is going to be in quadrant 1. So that means that my x is going to be u and my r is 1. So x equals u. We don't know what y is yet. That's what we need to solve for. And then r is 1. Okay, so then we have x squared, which is u squared, plus y squared equals 1 squared, which is 1. So then we have y squared equals 1 minus u squared, which is y equals the square root of 1 minus u squared. So the square root of 1 minus u squared is our y value. Okay, so we're going to go back and plug in. So sine of 2a, which is sine of 2 cosine inverse u, is equal to 2 times sine of a. So sine of a is going to be y over r. So it's going to be the square root of 1 minus u squared over 1. And then we have cosine a, which is x over r, which we know is u. Okay, so you can get that from x over r here, or when we solve it right here. So this is going to give me 2u times 1 minus u squared. Example 8. Okay. The optimal angle of elevation theta for a shot putter to achieve the greatest distance depends on the velocity v of the throw and the initial height h of the shot. See the figure below. One model for theta that achieves this greatest distance is theta equals arc sine of the square root of velocity squared divided by 2 times velocity squared plus 64 times the height. An athlete can consistently putt the shot with height equals 7.5 feet. Okay, so we know height is 7.5 feet and velocity is 50 feet per second. At what angle should he release the ball to maximize distance? Okay, so we're just going to plug these values for h and v, so height and velocity, into the formula that we're given. So we have theta equals arc sine of the square root. We have 50 squared in the numerator, and then we have 2 times 50 squared plus 64 times 7.5. Okay, we plug this into our calculator, so we would just take sine inverse of all of this, and we will get, so let's plug that in. So make sure we are in degrees here, and then sine inverse of the square root, we have 50 squared divided by, make sure you keep your denominator in parentheses, 2 times 50 squared plus plus 64 times 7.5. Close that off. Approximately 42.5 degrees. Okay, but that is approximately 42.5 degrees.